Okay, so yeah, I wrote this last spring, I guess. So and I probably taught it in my Math 140 last year, just as a review. Okay, so let's just go to the beginning of this file here. Okay, so page 3. And so again, and I might have talked about this a little bit in Math 130 at the end, and it was kind of fast. So Math, those a couple of you took Math 130 with me, and we know that at the end of the course, like the last few weeks of the course, we learn how to write a user-defined class, and we know how to write a constructor. And to be honest, I think I talked about multiple constructors, though I can't quite remember if I did. It probably wasn't a lot because it wasn't really a lot of time. So let's just review this. And then, so yeah, your next quiz you'll write multiple constructors. People are chatting with me. What is it? What are they saying?
Are you sharing something? Because it still looks like you're trying to open up the PDF, I believe.
Okay, so you're not seeing the PDF file? So
No,
you don't see multiple constructors right now?
no.
Okay, I'm going to stop sharing and see let me figure out. Okay, I thought I did this right. Okay, so share screen. Okay, so let me just open multiple. Okay, let me do it this way. Share. Okay, so okay, so share. Now do you see it?
Yeah.
Okay. Actually, I'm not sure what I did wrong before. Okay. Okay. So multiple constructors. Okay, and then so we're going to talk about how to write a class with more than one constructor, which is probably something that was, if I mentioned it last class, it was probably really quite fast. Okay, so we'll see an example of how to write it. So last semester we learned, or whatever course you took in the before this introductory programming Java course anyway, you write constructors and other object-oriented programming languages. Yeah, so you write a class and you learn how to write a constructor. And so what the constructor does is the whole point of the constructor essentially is in the main method. Let's say you're writing a person class and you go new person. The constructor just initializes, it sets the object up in memory, initializes the instance variables. For the most part, that's what, for our course, that's what it did. And so, so let's just look at this really great example I have right there. So now you should be seeing this class called Circle, public class Circle. Everyone sees that? Okay, it has 3 instance variables. Okay, radius, x center, and y center. And when we create, so just remember, when we create a circle object, like in the main method, so when you create a circle object, memory is allocated for every instance variable. So we want to be careful about, let's just not, when you define an instance variable, it shouldn't just be for convenience because it makes it easier for you to write your methods. There really should be a purpose to it. So our circle, not only is going to have a radius, but we can actually change the center from 0, 0. Also remember, okay, so every instance variable has a value. So if we don't assign it a value in the constructor, like any kind of numeric instance variable has the default value 0. Okay, so you see there's that first constructor, and that's the kind of thing we would have learned in Math 130. And then, and you can see there what it does. It's taking the input parameters and assigning it to the instance variables. Okay, oh, but look, we have another constructor, constructor 2. In this case, the first one has 3 integer parameters. The last one, the second one, has 1 int parameter. Okay, so, and that's how the Java programming environment distinguishes between the 2 constructors. The first one, so it doesn't just look at the name, it looks at the parameter list, right? So there's no ambiguity. If I try to call, and you'll see in a second, I have an example, but if we try to create a circle object and we pass in 3 integers, we have to be calling constructor 1. And if we try to create a circle object with just 1 int parameter, exactly 1, then it must be 2. It must be constructor 2. Let's say we try to create a circle object with 2 integer parameters, 2 integer arguments. We'd get a compiler error because there's no match, right? So just based on this code that you see right there on slide 4, we can either create a circle object with 3 input parameters or 1 input parameter. And of course, then you can write additional constructors if you want. Okay, so there's an example of multiple constructors. Also, students, see that second constructor, we could also write this. We could just set the center, X center and Y center to 0, right? Because if you're not going to, X center and Y center are defined as ints, right? And if you're not going to assign them a value, they get the value 0. Because the one thing is that all instance variables must have a value, because when we create a circle object, we're allocating memory. And I'll show you in a second. So there we have these two great constructors. And so students, this is the slide I've been waiting for. And so when we create it, so I'm going to try to draw on the screen. So let's say when you so look at that, we go C1. We're creating a variable, a circle object variable C1. So that new, it means allocate. So we're going to allocate memory for a circle object. So new is allocate memory. We're going to allocate memory for a circle object. Remember, the first argument is for the radius. The second is for the X coordinate of the center, and the third one is for the Y coordinate of the center. And when we allocate memory, we're reserving memory, we're reserving computer memory. And what's assigned to C1 is actually the address where we can find that memory. So I'm going to try this, students. So C1, so we're going to actually, so for every instance variable, there's memory reserved. Oh, that didn't look too good. That wasn't good. I think you can't get too close to the edge or something. So this isn't maybe the best. Okay, so we have 20, 1, no, 11 and 1. So this would be Y center, right? So and this would be radius. I won't put X center because I'm running out of room. So but every time you create a circle object, there's memory reserved. And so let's say this is at address. So remember, so what's actually stored in C1 is not the actual data stored in the object, it's the address where we can find the object. So let's just say this is at address. So let's say we don't actually know the address. There's no way, Java does not allow you to find the address where an object is stored. But let's just say it's stored at address 1024. That's what's assigned to C1. So see, this is an assignment operator. So the new operator allocates memory, and then the address is assigned to C1. And then we can print out, we can use the get methods to print out the center and the radius. Okay, so now here's an example, because now, so we're creating another circle object, only we're using the second constructor. So there's absolutely no ambiguity about which constructor is called. How many are, so let me just go back up here 1 second. You see there's 3 integer parameters, arguments in there. So the compiler looks at that and says, there better be a constructor in the circle class that accepts exactly 3 integer values. And luckily there is. We go up there, well, we wrote it so we know. But yeah, so we can see, oh yeah, there is one. So the compiler is happy. And then the compiler sees C2, goes, oh, there better be a constructor in the circle class that accepts exactly 1 int parameter. Oh, and we go up there, oh, and there is. But there's no ambiguity about which one to call, because the parameter list is actually part of the method name. And in this case, when you print out for C2, when you print out the center, you get 0, 0, because we're assigning 2 to the radius, and the X center, and the X coordinate and the Y coordinate of the center are automatically 0. Okay, so this is a point. Now this is the highlight of this part of it's got like many highlights. It's like for those who are taking calculus with me, it's like a sine wave. Okay, yeah, so we're about like at sine pi over 2 right now. Okay, so okay, yes, okay, so the keyword this. Okay, this is what I want us to learn, and I don't think I mentioned this last sem. Just briefly, those of you who took the course with me, we used the Xylab, and the Xylab didn't really use I think it did mention it, but it didn't really emphasize it. Yeah. So I'm not sure. Yeah, maybe Marcos, you remember this. Yeah. So a constructor can invoke another constructor in the same class with the keyword this. So there's actually 2 uses of the keyword this. Okay. So here's the example on the next slide. Okay. So suppose I want to. Okay. So do you see here how we have the 2 constructors? I didn't put the gets in this anything else in this because there's not enough room. But see, here's the second constructor. It takes exactly one integer parameter. And so, but instead of writing, again, this is a little contrived. I'm not saying this is the greatest way to do it. This is just an example. Okay, so what's the first statement in there? It's this left paren. Do you see how I'm going this left paren? That means call a constructor in the same class. So there's two uses of the keyword this when we write a class. We can go this period, right? Like see here, it's this period. See, we got that's usually used when you're you're trying to access an instance variable. Okay, so this dot radius, like that would mean, oh, let's use an instance variable from the class. When you go this left paren, that means call a constructor in the same class. Okay, so how do you know which constructor to call? Well, there's three arguments in there, right? Radius, 1 and 2. So whatever in radius is passed up here, and then 1 goes to X center and 2 goes to Y center. So you'd actually be calling the second constructor, the one with one parameter, calls the constructor with 3 parameters. And so for this example, whenever you create a circle object and you just use one argument, the center is automatically at 1, 2. It defaults to 1, 2. And that's just, I just made those numbers up. I mean, I didn't make up the number 1. I just picked those numbers just for an example.
Could you put a number for radius instead of
the
radius?
Okay, remember the radius, you could, but in that case, then the radius is always going to be fixed. In this case, the radius, I'm not sure I have an example on the next slide. Here, let me take a look. Can't remember. Yeah, see, it's like here. So let's say in the main method, you go circle C is new circle 8. Okay, so 8 would get passed to radius, and the center but you have no choice about the coordinates of the center. It would always be 1, 2. So in this case, the center would be 8, and the center is at 1, 2. Did I answer your question, Philip?
Yeah, thank you.
Yeah. And then you can actually write a constructor where there's no parameters, and you just assign there's just a default value for the radius and the coordinates of the center. The point of this, though, is just to show you the thing that's important here is just this is this thing. Let me erase this. It's getting a mess. This is what I want you to understand is that's the highlight of this class. That's a highlight, not of the class, of for right now, for the next 5 minutes. Okay, so okay. Did I say everything? Okay, there's only a little bit more left to say. So if a constructor invokes another constructor with the keyword this, then it must be the first executable statement in the constructor. This is the only thing left to know. Do you see how here I'm calling this, but it's the second statement? So this is the first statement right here. And so if you actually type that in, you get a compiler error. So if you're going to call this, if you're going to go this left paren to call a constructor in the same class, then it must be the first statement in the constructor. So to fix the problem, you would just exchange those statements. And I think you know everything I know about using this to call another constructor in the same class. There's really not a lot to, I think students forget this a lot. I talk about this in class, and then I see sometimes they forget it. So I guess one theoretical possibility is they're not listening to me. This is what I would do when I was a student. I wasn't listening. And then, but don't do that. But the other thing is, I think we don't use it a lot. So you don't use it, you forget it. You don't really see too many examples. You don't really see too many examples of this. Yeah. So this with the left. There's some nice examples in this algorithms book by Sedgwick, but it's more like it's super. Super is I'm going to review that next time. So next time I want to review super, and I want to talk about complexity. And then I want to talk, and then we'll maybe talk about one of the algorithms, and then you'll have your exam, your first test. Okay, so let's see here. Okay, so any questions about this? I wanted to, now we're going to look at an example online in the person class. So now I want to talk about, so we talked about multiple constructors. I'm trying to think what else I wanted to, well, I just wanted to show you an example of the equals method, like the full equals method, which I taught you a version of Math 130, again, really quickly, because everything went so fast, right? At the end of the course. But I want to teach you the full equals method. And because the idea is that, like the equals method allows us to compare objects from the same class. Let's say we write two person objects, and we can say, oh, are their first names the same? So we have these two different person objects, but are their contents the same? Are their first names the same, the last names the same, and the ages are the same? But the thing is that the equals method actually allows us to compare objects of any kind of object. Like we compare our own person object to a string. But if you're comparing objects from different classes, it should always be false. So if I try to compare a person object to, let's say, like a book object that I write, I should write, the equals method should be written in such a way that you get false. Or also the keyword null, that's a value that we can assign to an object variable. So if we compare like a non-null object to null, we should get false. So that's what I want to show you. And then I want to show you, and then I have an example in this person class of multiple constructors, and also and just a more complicated version of, I can't remember if I erased it or not, of the, of comparable, something a little more complicated than we've done. So, but any questions right now? Okay, so I'm going to open up Eclipse. Okay, so then, okay, so I'm going to take, so just so I'm going to take this out just so maybe it looks like I'm writing it live here. And then, I'll take all this out and we'll go back to this. Okay. So, okay, so students, so first of all, why don't we notice one thing here is that, okay, so we actually have three constructors. So does everyone see the person class right now?
Yeah.
Yeah, that's all I need is one person to see it. Okay. So, okay, so and there's three constructors, right? There's the one that initializes every instance variable. Remember that data is coming from the main method. Right, because whoever I'm assuming that the person objects are actually being created in the main method. And then we have a second constructor where the user passes in a string for the first name and for the last name. But if you only use the constructor with two parameters, the age defaults to 20. And just remember, we're going this left paren. Okay, so that means call the first constructor. So sometimes I ask students to do this, write a constructor with two, with first name and last name, and initialize his age to 20 and use one executable statement. So this is the wrong answer. I get this typical wrong because they forget how to use this. This is what I see a lot. They just do it. I mean, this is perfectly okay, but they're not actually answering the question. I want students to show that they know how to. This dot age is 20. See, this would be, it's equivalent, but if the question is, use the second, write us a constructor with parameters first name and last name, and the age defaults to 20, and do it with just one executable statement. Well, these are three statements. So I want to do all of this with just one. So the way I state my problem is, do this in just one statement. So, okay, so, I mean, it answers, I mean, it does, so the lines 26 through 828 do the same as line 23, but if I say do it in one executable statement, then that would be wrong. So I will just uncomment I'll comment this, and now uncomment that. Okay, so then also now we have the person class. I mean, person, I've been talking all day long, so sorry. Person with empty set of parentheses, no art. Okay, so if we use the third constructor, it would create a person object, but it calls the constructor in line 14, constructor one. And in this case, Pilar is assigned to first name, S is the last name, age is 54. And so in this case, the first name defaults to Pilar. So if you use the constructor with no parameters, the name would default to Pilar, last name S, and then age is 54. Okay, so the rest of this looks the same. So the new thing so far is using this to call multiple constructors might be new. I don't think it should be. I'd have to go back and review. I do with Math 130. It's not a big deal if you haven't seen it before, but using this to call another constructor is probably something, maybe I went over super fast. I doubt I ever talked about it. Oh, there's our friend, the two-string method. Okay, so students, let's talk about the equals method. It's there on line 70. And so this, I know we did this a little bit. I keep saying, hey, no, isn't that saying, well, did we? I think we did. Okay, students. I think, yeah, I think I had to add some information to the Xylab book because they didn't really talk about it. Yeah, thanks, Marcos. And then, yeah, you remember. Okay, your memory's better than maybe you should teach the course. No, I just, yeah, I'm pretty sure I have this vague memory of teaching the equals method. Okay, so equals. Okay, this is what we learned. Look at line 81. Okay, let's just look at lines 81 through 83. That's what I taught in Math 130. That's all I taught you. So let's say if I wanted to write an equals method for a person class, see, what is the input parameter for the equals method? It's object, and then you give the, OBJ, that's just a parameter name. It's it's not any legitimate parameter name. Object is the highest level class of all. So let me just say this, every class in the world has an equals method, right? Remember the top level class is object, and the object class has two public methods in it, toString and equals. So every class in the world from day one, like those of you who took me in Math 130, the first day we wrote like a test class, and we did like a hello world program. Well, that class had a toString and an equals method in it, even though we don't see it, because we're inheriting it from the object class. So every class in the world inherits a method equals with the input parameter object. Okay, it will not do anything useful. These toString and equals will not do anything useful unless we override it and make it do something useful. Okay, so we're going to make it do something useful here. Okay, and so what the goal is, okay, so this is in the person class. So if OBJ is passed a person object, we'll compare the instance variables to see that they're the same. And if they are, we return true, otherwise false. If object is null, we return false. And if OBJ is a non-person object, let me say it. So if OBJ is a non-person object or null, we return false. So I'm going to do this. So some other books aren't like real big. For this course, I'm just going to use one return statement if possible. So I'm going to assume that the method returns false. So they're on line 71. I just said, let's just assume, and then we'll change it to true if something else, arises. Okay, so I say to myself, well, if object is not null, so if so let's say OBJ is null. That means that OBJ not equal to null will be false, and then we go automatically to return flag, and we return false. This might be new, and this dot class equals object dot get class this dot class equals object dot get class. Get class will actually return the class name for the object. So if OBJ is actually so OBJ dot get class, it will be the whatever the class type is for OBJ. So if OBJ is a person object, so this dot class, because this is the person class, this always represents the calling object. And then we'll look at a main method to kind of clarify this. So this is in the person class. So this dot class will be person because we're in the person, because we're writing a person class. And OBJ dot get class will be whatever class that we pass in. So let's say we pass in a string class. So what we'd be doing here on line 76 is, so let's say the object is not null, but the object is a string class, what we would be doing would be carrying person to string, and once again, it would be false, and we automatically return false. So if the object, so let's say if the object is null, or if the OBJ is not a person object, we automatically jump to return flag and we return false. So let's say the object is not null and the input object is really a person object. Okay, so the next step at line 77 is kind of an optimization step. I'll uncheck it. Maybe OBJ and this they have the exact same address. Maybe they're pointing to the exact same place in memory, in which case it's automatically true. So that's just an optimization step. That way you don't actually have to compare the instance variables. That's only, I mean, if you're doing a lot of computation, that could save a little bit of time. Okay, now we get to the Math 130 part, so else. Okay, so let's say OBJ is a person object, a non-null, it's a person object. It's a totally different object than the current object. So this is what we have to do. We have to remember OBJ, the compiler thinks OBJ is an object variable, right? Okay, so remember the compiler kind of is parsing our code like a word processor, make sure we didn't mess up anywhere and everything is spelled right. But the only thing that the compiler knows, it sees this variable OBJ, looks to the left, sees object, that's all the compiler knows, right? Because there's these two phases. The compiler, runs through the code, checks everything is spelled correctly, and if everything is okay, creates a .class file, and then the Java runtime environment then executes our .class file and runs it. Okay, but as far as the compiler is concerned, OBJ is just a object variable, and it doesn't have instance variables like age or first name or last name. So we have to cast OBJ to a person object, and that's what we do in line 81, because we want to be able to access the age and first name and last name instance variables. And then in line 82, I don't know if it helps if so remember, we always start on the right side of an assignment statement. Maybe this will help if I put these parentheses in. So let's just start on the right side of the assignment statement. And all we do there, we're checking to see if the instance variables are identical, right? So first let's compare the integer, the age. Age is an integer, the age instance variable is integer. So let's compare them. And an integer is int, they're compared with the double equals operator. Okay, so first let's compare the ints. And it's faster to compare integers than strings, so I start with that. It's not that big a deal. Okay, now if you want to compare strings, you have to take advantage. See, remember first name and last name are defined as string? Well, the string class has an equals method. So do you see here, like we're going this dot first name dot equals p dot first name? So we're comparing if the first names of two person objects are identical. And the first name instance variable is a string, and we compare them with the equals method. Remember the equal, you can actually compare strings with the double equals operator, but you're comparing addresses. You're not comparing contents. So when you're comparing object variables, you always want to compare with the equals method. So this dot first name equals p dot first name. We're comparing the contents of the calling object first name and the input object's first name. Okay, so let's say that's true. So then we do the same thing with last name. And if all those Boolean expressions are true, this dot age is p dot age, and first name equals p dot first name, and this dot last name equals p dot last name, flag gets assigned true. If any one of them is false, flag gets assigned false, because those are and operators. So and means every individual piece of the Boolean expression we use and, every Boolean expression on either side of the ands have to be true for the whole thing to be true. If any one of them is false, then flag gets assigned false. So that's all there is to it. I know I made a long explanation, but that's pretty much all there is to it. And so we'll probably have, I'm not going to test you on this, but you'll have I'm sure at some point we'll have an assignment and I'll remind you of this example. But this is kind of the template. Yeah, sometimes students have a hard time writing, but you just look at this example. Initialize flag, no matter what class it is. Start like line 71, flag is false. Just assume the equals method returns false. And then we do a bunch of logic in between. Oh, and then the last statement is return flag. And then do some logic in between to see if we should set flag to true. But the first part is like line 76 through 79. You can do that for any equals, like 71 through 79. Or I'll say one more time. 71 through 80 could be put in any equals method for any class. And then also the last line, 86. And it's this, it's what's in between the else. It's what in the else block. That's what's a little bit different. But the idea is the same. You cast the OBJ to whatever the current class is, and then you compare the instance variables. So any questions on that? I mean, it's a lot of talking on my part. Philip, do you have a question?
Yeah, can you use the equals method for this age, or do I have to use the 2 equal signs?
No, you have to, because remember, age is defined as a, here, let me go up. See, there, so age is int. Age is a primitive type,
Right.
int. So the primitive types, and those are the variable types that are spelled lowercase characters. I've got, you see lowercase int. That's the first, one of the first things you learn in Math 130.
Oh, right. Okay.
That you have to compare with double, because it's not an object. It doesn't have methods. Where like first name and last name, they're defined as strings. They're objects. They have, and the string class has a equals method. So does that help?
Yes, thank you.
Okay. Yeah, that's a common error, because to compare like integer int with dot equals, you definitely have to, yeah. So like double lowercase d, you compare it to double equals, or car, like char, the double equals, but like string or like string uppercase s, any kind of variables that start with the upper, the variable type starts with an uppercase character, you use the dot equals method. So that's and I have this very exciting example that I'll show next time. There's only so much excitement per lecture, students. So, and then so any questions right now? Before I wanted to do one thing here, and then we haven't done the exception handling. What was the first thing we did here? So no, we haven't done the exception handling yet, have we? Okay, yeah, I did the constructor. Yeah, I did the multiple constructors. And now we're doing this. Yeah, we still have to do the exception handling. Okay, so let me just do this. Okay, let's just look at this. Let's just look at test person, and then I'm just going to do a little bit with okay, so what? Okay, so I don't know why I did this. So let's yeah, because I was doing some stuff. Okay, let's get rid of this, and we'll just students, I'm just gonna, we'll use this later, and then yeah, okay, so let me see here. So we'll just use this right now, and then this I will. And okay, so and then this stuff we'll just look at later. So if at all, so I did something I didn't want to do. Yeah, so this, yeah, this and this is something we definitely, okay. Okay, so and then so I think we can handle this. Okay, so anyway, so students, so let's just look at this example. So in the main method, I have an array of person objects, and what is there? 7 person objects, and there's even a null in there. Right, so there's a null in there, and so we're going to use all the constructors to create a person object. And let's see, so then we're going to display the names. And so they're line 21. So I'm using a for each loop. And students, when you just put an object variable in the print line, it actually displays the result returned by the toString method. So I could also, this is equivalent to going .toString. It's just kind of some kind of special rule. But usually, yeah, usually just go, so if you want to print out the toString method in a print line, we typically you just see the object variable name. Okay, so then we're creating a new, so line 25, we're creating a person object called person, and the first name is Pilar, and then it's, the last name is G, and the last name is, the age is 45. So Pilar G, age 45. And if you look in the array, person array, I have 2 person objects where this exact same content, first name Pilar, like on line 11, last name G, and then 45, age. In line 13, there's another person object with the exact same contents of person defined in line 25. So now what we're going to do is, so like starting there on line 37, we're going to, maybe it's 38 here. Yeah, 38. we're going to just print, okay, so this person object right here, let me just put this above here, so it's, okay, so we have this person object. Okay, so we have this person object, okay, and same content. So now we're looping through the array. And anytime if person equals P, so person is, remember, it's a person object, first name Pilar, last name G45. So if person is equal to any of the objects in the array in line 9, it prints out true, otherwise it prints false. So it should be, false. Like, so here would be false, false, true, etc. I'll do a few of these. And then true. And then when you get to null, it should print out false, because we said if we go person dot equals null, we should get false. And so, because let's just run this. And that's what happened. So we printed out all the names, and then we got false, false, true, false, true, false, false. Because objects 3 and 5 had the exact same contents as person. So, okay, so again, the null actually returned false. So, so let's see here, students. So let's just try a couple of other things right here. Okay, so I'm going to just, any question on that? So let me just see, I'm just going to comment this out. And I want to comment this out. Let me just demonstrate a couple of things here, kind of. Okay, so let's just create a person, see. See, it's a totally different object here. Oh, let's just put this up here. So I know I'm moving a lot of stuff around. Oh, shoot. Okay, so yeah, so students, sorry. This we'll get to, okay? Sorry, I'm getting for the confusion. Let's just see, I have that, so it's a little bit messy, students, I realize that. So let's look at line 32 and line 33. I keep commenting this out when I need it. Okay, so here we have this person object. So we have person. So now we're going to compare person to cat. And why doesn't it like this? So now we're going to compare person to cat. So cat is a string. So this is a string, line 32. And so then line 33, we're creating a person object. And now we're going to compare a person to a string in line 34. And so we should get false. We should get false. So let's just see, it should only be one line of output. Yeah, and it's false. So remember, so students, so what's happening here is you're going line 30, person is, so if we go, I'm just going to open up the person class again, but like that person object is the calling object. So that would be like this in our equals method, and str would be the incoming obj. Okay, so let's see where that comes in now. Do you see how, so how did that get, when we compared the string to a person object, how did we get false? And see, can you see that line 76? It's from this dot get class is equal to, equal obj dot get class. So for example, on the other page, this was a person object, and the obj, for example, was a string. So what this dot class would return person, and obj dot get class would return string. So that's how so when you compare a person object to anything that's non-person, you will automatically get false. So that's at line 76. this is what allows us to compare classes from different objects. Okay, so we cannot do, so this allows us, so by the time you get to line 81, it's safe to do, you're guaranteed to have a non-null person object and you can do the cast. So, Philip, do you have a question?
Yeah. Real quick. So when you go back to the test person.java,
Oh, test person?
yes.
Okay.
And then it says new, it's on line 14. I'm just confused. It says you use default constructor. I don't remember where the,
Oh,
what
yeah,
the default.
remember that default constructor. So go, let's look in the person class. Remember I had 3 constructors? It's this one right there in line 32.
Okay, got it.
The default constructor is a constructor with no parameters.
Okay.
So, yeah, so I was just using that. So in that case, so line 14 would create a person object who's, with the first name Pilar, last name S, and age 54. Okay, but so I'll put these files up probably tomorrow if I haven't done it already. The whole point was to show you how to write this equals method, and I'll definitely, if we need to use an equals method in assignment, I'll definitely refer you to this. So it's really not too bad, but again, just follow this template and it'll work. Any questions on the equals method? So, I know it's kind of fast, especially when I'm, until you actually sit down and write it, it can be a little confusing. I want to do one last thing with this equals class, this person class, and then we'll go back to test person and try it. I wanted to do an example that's a little more like a comparable example that's a little more sophisticated. So this is what I kind of erased because I already did this in the other class, so I had to erase it. I forgot to erase it. So let's go implements comparable. So the name of the class is person. So in the diamond operator, I better put person. And now I better have, oh, see that you get that red dot? Because when you implement comparable, you better have a compare to method. Okay, so remember it's public int compare to. Oh, and so what's in the diamond operator? It's over in the diamond operator. That's what we put as the parameter. Let's just call it P. So the class name is P, the diamond operator, no, the class name is person, the diamond operator is person, the parameter for compare to is person. And so what I want to do is, I want to look at all 3 instance variables, first name, last name, and age. And I'm going to do it, so we're going to first compare by last name. And kind of like alphabetical, or like they would do like in a dictionary. The further back the last name would be in a dictionary, the bigger it is. And but if the last names are the same, well, let's then take into account the first name. And again, the first name, whatever, if the last names are identical, like say they're both Smith, let's take into account the first name. And again, the first name that's the biggest first name is the one that's nearest the end of the dictionary. And if the first name and the last name are the same, can take into account the age. The older person would be the older. That's only if the first name and last name are the same. First, let's compare last names. If they're the same, let's check the first name. And if that's also the same, compare the age. So I'm going to see if I can do this with one return. It doesn't have to be done with one return, but I'm going to do this. So int compare, and I'm just going to assume, we're going to take advantage of the fact that the string class has already implemented compare to, right? So the string class has this built-in, the string class is implemented compare to, and it uses that rule. The further back the string is in the dictionary, it uses dictionary ordering. The further back you are in the dictionary, the bigger it is. And I'm assuming that all the characters are of the same case, right? Because lowercase is actually bigger than uppercase in Java. But, okay, so I'm assuming the cases are all the same. So what I'm going to do is this dot first name, and it's got to compare, first name is a string, so it's got a compare to method. So this dot last name. Okay, so, and that's either going to be, remember the compare to method returns an integer, right? So if this dot first name is further back in the, I'm sorry, last name, that's not good. Okay, so, and this is, God, this is bad, isn't it? P, I don't know what, I can't talk and type at the same time. So, okay, so if this dot last name is further back in the dictionary than P dot last name, then it returns positive. If it's earlier in the dictionary, it returns negative, and if they're the same, it returns 0. Okay, so let's just return compare. And now the method will compile, though it doesn't do everything. The logic needs to be fixed if the compiler's happy. All the compiler cares about is that we're returning an int. Okay, so now, right, okay, so remember this is the calling object and P is the input argument. Okay, so let's say compare is 0. So if compare is 0, that means the last names would be the same. Now let's look at the first names. Okay, P dot first name. Okay. Now let's say the first names are the same. So if compare is still 0 after checking the last name and the first name. Now we'll use the age. Now, but we can't, okay, so remember age is an integer, int, it doesn't have methods. It doesn't have a compare to method. So if you want to compare like integers, ints, you have to take their difference. So now compare will be equal to this dot age minus P dot age. And if, so if the age of the calling object is greater than the age of the input argument, then on line 41, compare would be positive. And so that's it. So it's a little just more, I like this one, it requires more line. So the ones on the quizzes should just be one line, or you could do it in one line. But here, you had to maybe just, the logic was just a little bit harder, not super hard, but, first we'll compare the last names, then we'll compare the first names, and then we'll compare the last names, and if they're identical, then we'll compare the first names. If the first names are also identical, just return the difference of the ages. Okay, so remember the compare to method for string returns positive if the calling object is greater than the input object. So this will return a positive value if this dot last name is greater than P dot last name. If the last names are identical, it returns a positive value if this dot first name is greater than P dot first name. And if the first names are also identical, if this dot age is greater than P dot age, compare is positive. So why don't we unless there's a question, let's just get a quick example. And then I'm going to, students, anytime you need to leave, I understand. I mean, I don't take attendance. So if you have something, if you have studying to do or whatever, you have something to do, I'm not encouraging anyone to leave, but if you have something to do, I understand. Okay, so let's go to test person. You're not going to hurt my feelings, basically, is what I'm saying. Because this is going to go over a little bit. Well, someone's chatting with me.
You said good night.
Oh, okay. Have a great night. Okay, so let's look at the test person, and let's check out our compare method. Okay, so test per. So it did it right here. Okay, so I'm sorry, I have all this stuff from all over the place. So let's just comment this out. It's right here in the middle. So we have this person object. So line 25. Sorry, I know it's a little bit of a mess. I got all this kind of. Okay, so person is P large G. Okay, person 2, the last name is ZZ. So person 2 should actually be greater than person 1. Right? So when we compare the last names, what's going to happen here for this case? We're going to go G dot compare to. Effectively what we're going to be doing is this. And that's going to be, so this is returns negative because G is before ZZ in the dictionary. G is actually smaller than ZZ. So the closer you are to page 1 in the dictionary, the smaller you are. Okay, so you should it should print a negative value. Yeah, we get negative 19. I think what it's printing is the difference between, I'd have to, Z is letter 26. What is G? Is it letter 7? Yeah, the difference between G is the 7th letter and Z is the 26th letter. It's taking the difference between the two. It's 7 minus 19, but that's not important. All that's really important is that it's negative. Now, if we change this, so let's say the last names are the same. Now we should get, now Pilar is greater than Bill, so now we should get a positive. So now let's just try it one more time. So now we're basically going, now it's going to be Pilar dot compared to Bill. Should get positive. And you get 14. And then, yeah, once again, B is position 2, and I'm going to guess that P is 16. What do we get for the output? The difference was 14, yeah. So, well, B is definitely the second letter in the alphabet. So I'm going to guess that P is the 16. Okay, so, yeah, S, because S is 19, yeah, P, yeah, I think that's right. Anyway, but in this case, you get a positive number, you get positive 14. Right, so we ran that, we got positive 14, there we go. And so that means, so that would mean that in this case, Pilar G 45 is greater than Bill G 48, because the last names are identical and Pilar is further back in the dictionary. So that's the comparable example. So any questions on that example? This might become useful for one of our assignments later on. I also just want to show you, how in both in the equals method and in the compare to method, our compare to for person took advantage of the compare to in the string class, and then the equals method for the person class took advantage of the equals method for in the string class. So
I got a question.
yeah, go ahead.
What if, let's say they have the same first letter of the last name, but like the second letter is different? Like,
Yeah, then they compare. So what it does, what this compare to method does, it compares like the first character for each string, and if they're identical, it goes to the second character.
okay, and I'll show the difference between the second
Yeah.
characters.
So let's
Yeah.
try that. I think that's what works. So Pilar, Bill. So let's make this Bill. I don't know. I don't know. I'm gonna make up a name. Bryce. How about Bryce? I think that's a name. I don't know. It is now. Okay. So now it'd be R minus I. I think R is 18 and E, F, G, H. I think I is 9. Let's see. So now it would be taking the difference of the R and I. I think that's what it's doing. Yeah, we get 9. So let's see. Positive 9. So I is,
that makes sense.
yeah, so yeah, R is position 18, and I think I is position 9. So yeah. So the B's are the same. So then it compares lowercase r to lowercase I. The thing you have to be careful about is when when it's different case, and then it doesn't work.
Is there any reason why you compare last names first, or is it just because?
I think that's kind of common, that like when you alphabetize a roster or something,
Okay.
Or like in the phone book. I don't think they have phone books anymore, but yeah, there used to be, phone books, and it'd be by last name, or even like in a library, maybe like I guess now they use I guess novels are alphabetized by author's last name, but yeah, it'd be by last name, and then
Okay.
if the last name's identical, then you look at the first name. But you don't have. I mean, you can basically set any rule you want. You can sort by. You could do first name and then last name. It's up to you. So there's no, remember, the user, the programmer decides the rule for the compare to method. So any other questions before one last exciting thing to do today? And this will take me about 15 or 20 minutes. And that's the exception handling. Okay, so okay, so, and this will not be on your quiz, because if it was proctored, I think I would put it on, but it's not. Okay, so let's see here. So it'll be just writing maybe some more methods, and then doing multiple constructors. I'll put an announcement up tomorrow. Hopefully I'll remember. Okay, so let's see here. I say that because I'm only, because I've been, the more I work, the more I forget. Okay, so let's see, here's this I think it's, what I want to talk about, exception handling, and I'm pretty sure I put the, and you should now see, there should be, this is pretty simple, but, and we're gonna probably use this later on for one of these, maybe even the next assignment, maybe we'll do that. You definitely need it for the array list class, and for some of the data structures I want to talk about, either linked list, we need it, and definitely for array list. Okay, so does everyone see introduction to exceptions?
Yes.
Yes.
I just need to get one person sees it, then everyone sees it. Okay. Okay. So, and so the thing about Java is unique in that in some cases, it forces you to put in exception handling. Now in Math 130, we never did it. And if that's all you've had in Java is like a course like Math 130, it's likely you haven't, unless your Math 130 teacher decided to include it, you probably haven't had exception handling, because it's only, if you do input, let's say in Java, you try to open up a file for reading or writing, then you have to use exception handling. Anytime you do anything with input output, Java forces you to use exception handling, or you get red dots, you get compiler errors. But let's say like index out of bounds, like you do an array index out of bounds. Well, that's your program crashes and you get this error, array index out of bounds. Where you're trying to use an object that's set to null, like maybe you're trying to get the length of a string that's been set to null, you get null pointer exception. And then I'm going to talk about one called number format exception too. Okay, so exception, so it's just a technique for catching errors that prevent our programs from crashing. And that's what we want. That's what good programmers do. And sometimes you go to, I don't think you see it so much. The school's website used to crash a lot. And it would do things that maybe it really shouldn't do. Like it would say, error in database at line blah. It kind of would give you information about the underlying database because they didn't handle the exception. And so now it kind of maybe exposed some private information that could, maybe easier to hack the system. I don't know if that information was that critical. Now I don't think, I haven't seen the school's website crash in a long time. But yeah, so instead of getting like these error messages, like a DOS window, array index out of bounds, what it is you get your program continues and your program just exits gracefully. So you don't see some kind of like ugly error message. Okay, so exception handling is intended to catch problems beyond the programmer's control. Let's say opening up a file that doesn't exist. So you write this outstanding application, it's been running for like 20 years, and it keeps opening up a file, and a new system administrator comes along and changes the file name or changes the password, or maybe the file, or maybe the file just gets filled up, we can't open it, there's no more memory. But let's say we just, for some reason, all of a sudden we can't open up this file that's been working for a long time. So that's beyond our control. Or let's say the user enters, it's like a web page. So there's all these text boxes and the user enters data in the wrong format, like entering, let's say like a zip code. Let's say they're supposed to enter an age and they enter ABC. So they enter, non-numeric entry when there should be numeric. So we can't really control what the user does. Just drink some water here. So we're gonna put what are called try-catch blocks. It's pretty similar, like in some of the Microsoft languages, like C#. So I'm just going to expand this. And I remember Math 130 used to be a 4-credit course, and I would go through this in excruciating detail, which I kind of now regret doing, but that was probably too much for that class. But so there are all these exception classes built into the language. So when you install the Java development kit, you get all these exceptions. So when you get like index out of bounds exception, you're actually creating an index out of bounds exception object. And if you want, you could use that object to display some information about the exception. Okay, so the top level class of all, well, there's this throwable class, and that has a method called getMessage, which tells you, gives some information about the exception. But the top level exception class of all, it's just called exception. So like a index out of bounds exception is an exception, or an IO exception is an exception. Everything is every kind of exception is an exception object. And that's gonna be important a little bit later on. Okay, so then, here, let me just go down here. You don't need to know the class hierarchy though. Okay, so then, and I didn't create that diagram, somewhere I found it online. Okay, so yeah, that throwable class, that very top level class of all, what am I doing here? Has a method called getMessage, and so since like exception extends throwable, all the exception classes inherit, this method getMessage. So all classes have a getMessage. All exception classes, let's see, one of these exception classes has a getMessage method, which you can use to display information about your exception in case when it happens. So students, this slide here, well, it's on page 3. This is a lot of information right here, because there's really not a lot to try. I'm not going through all the rules, but for the most part, there really isn't a lot of information you need to know about try-catch blocks. So do you see, this is what's new. So students, this part here, this is what you would do if you weren't handling, like if you were in Math 130, you weren't putting try-catch blocks in your code. So the try part is the stuff you want to have happen without error. So we don't actually want an exception to occur, but in case one does, it's like insurance, it's like an insurance policy. We don't really want to use our insurance policy. We don't want anything to happen to our car or to our house. But in case it does, we have the insurance there. Okay, so the try block is like, the try catch block is like insurance. Okay, so you start at the try block. Oh, you declare an array of size 4. You initialize x of 4 to 0, but look right here. 4 is too big. The greatest index is 3. You get what's called an index out of bounds exception. So what happens is, before, if you only had those 3 lines, your program would crash. You get that DOS window, and at the top it would say index out of bounds exception, and maybe someone would raise their hand, professor, I don't know what this means. Anyway, now, well, not you students, but the first week of Math 140 or something. What happens is you would actually go to this, that's an index, that generates an index out of bounds exception. You go to the corresponding catch block. You print out index out of bounds at index. And I just happen to know that, well, first of all, I should say this. That line, this statement right here, x of 4 is assigned 0, it generates an index out of bounds exception object. See here, we actually give the object a name. We're going to call it A. And then we actually print out a.getMessage, because all the exception classes have a getMessage method. And it actually prints out just by, just by experiment. I know it prints out the index that causes the problem. Okay, so we start here, or we get to x of 4 is 0, then we jump to the catch block. We never go, once you're out of the try block, that's it. You never go back. We execute all the code in the catch block, and then we execute the first line after, then the program just goes on like, nothing happened. We go to the first statement after the catch block. Your program does not crash unless there happens to be another exception somewhere later on. So any questions on that? And students, probably about 80% of exception handling now. So it's really not so hard. I mean, I keep saying that, and I say, if you don't understand it, it's hard. Easy is what you know, and hard is what you don't know. How about this? Compared to other things that we're going to learn, it's not that hard. Okay. So you have this new keywords, try and catch, and so meaning they can't be used as variable names. You can't go in try. So the try block is where we want to put the code. We don't want bad stuff to happen. So hopefully nothing happens in that try block. So if all the code in the try block executes, we skip over the catch blocks. You go to the first statement after the catch blocks. If there is an exception, you go to the corresponding catch block and just execute the code in the corresponding catch block, and then just continue on with the code. So let's just look at a few examples here. Okay, so if you look at that try block, there's nothing wrong here. So you don't need the catch block. I mean, it's never used. Let me put it that way. If you have try, you have to have catch. There's actually something else called, I'm only partially right there. There's something called finally, which I'm not going to talk about. Okay, but for our course, a try block should be followed by at least one catch block. But in this case, we don't actually use the catch block. So what would happen is that we go, oh, nothing bad happened. So we go immediately to system.out.println. So you'd print out no error, and then after try catch. Because nothing bad happens. Okay, so students, so here's another one. Oh, but look what's the error, students? Isn't that array index out or index out of bounds? The greatest index is 3, right? Because it's right. The greatest index is 3. So so that statement that I circled x of 4 is assigned 0. It's index out of bound error. So do we have this exception? Let's go to the catch block. What kind of error are we trying to catch? Null pointer exception. So null pointer exception is when an object variable is null and you try to use it. So that's not a null pointer exception. It's like, let's say a string variable is null and we were going like, no, let's say we had a string variable x and it was set to null and then we went x dot length. That's a null pointer exception. So the catch block does not catch our error because the error is indexed out of bounds. So your program now crashes because we haven't caught the error. So any questions on that? And then, it's kind of fast, students. So some people say you should never ask your students if they have any questions. And I'm not quite sure. I think we're supposed to. I'm not sure what we're supposed to do. I'm going to ask. Okay. Or maybe because I'm going so fast, no one knows what question to ask. But I'm still going to ask if you have any questions. Okay. Okay. So students, do you remember exception? It was the highest class of all. So let's go to the very top. Let's go to the very top. Remember this great diagram we had up here? Hello. You remember this? I can't. What happened? Thought I could. I thought I could expect. You can still see that, right? Yeah. No one's complaining. So I assume you can see it. Yeah. Somewhere the menu that allowed me to make that bigger isn't there, but I can't. Yeah, I can't do that with my fingers. Okay. So yeah, so see the exception is the highest level class of all. Okay, so let's go back to that slide I left off at. So what I'm saying is that catch exception will catch all problems. See, the exception class catches all problems. So any kind of, because every kind of like index out of bounds is an exception error, and null pointer, so is it null pointer exception is exception. So when you go catch exception, it's like a wild card. So it will catch the error. So here you have this exception, index out of bound, and it will go right there. So it'll print out no error, an exception occurred in your code. So catch exception is a wild card, but they can present a problem for us. Okay, so students, there can be more than one catch block. This is probably the most complicated slide of all. Okay, so since this might be new to us, integer.parsint ABC. So what parsint does, it wants to return an integer. So it takes the double quotes off. So like here, I'll see if I can print this. So let's say I have 72. So this, this returns 72. It returns the integer 72. It takes the double quotes off. Well, there's an integer there, so it returns 72. But if I can't convert ABC to an int, you take off the double quotes, you don't have an integer. So that's called a number format exception. So we're in the try block, and now we have two. So you have two catch blocks, and the catch blocks just have to follow one another. So a catch block has to immediately follow try, and then you have all these catch blocks in consecutive order. And so it looks for the best match. So it starts at the first one. Oh, catch number format exception. Okay, so it prints out bad input argument to parsint. It goes right here, right? Because that integer.parsint ABC matches number format exception. Now let's look at a similar slide. Okay, so we still have, the catch blocks are in the same order, catch number format exception, catch exception. But now look at it. The first exception is now indexed out of bounds. And now it looks at the first catch block and it says, okay, that's not a match. A number format exception is not indexed out of bounds. Oh, so let's try the next one. Oh, catch exception. That's a wildcard. So what it will print, so it actually executes the code in the second catch block. And it should print out an exception occurred in your code. So we can have these multiple catch blocks, and then you have to, and then if an exception arises, you run down the catch blocks, from first to second, and you stop at the best match. It's kind of like if else if. If exception equals number format exception, do this, else do this. But then got to be careful with these multiple catch blocks. Okay. You have, so you have these multiple catch. The problem here is catch exception is first. So what did I say is that, when an exception arises, like this one right here, that's a number format exception. Well, first it's going to try the first catch block. Everything matches catch exception. And so what happens is there's no way you could reach this catch block here. So if catch exception is first, all the other catches become irrelevant. And so you actually get a compiler error. So catch exception must be last. And I think that's it, students. Oh, and students, then I have some other stuff which I'm not going to talk about right now. And maybe we'll come back to this later if we need it. We can explicitly throw an exception if we want. So that's like if I is outside the, like here, if I is outside the range of the if I is meant to be an index, an array index. Well, first of all, like if AR is null, we throw a null pointer exception. And if I is negative, or if I is greater than a.length, we explicitly throw array index out of bounds exception. So if you want, you can. We'll probably use this at some point. So we actually can write code that explicitly throws an exception. It's with that keyword throw. I didn't even talk about it in my last class. So students, that's it. So exceptions will not be on the quiz. We'll probably will be using it in some of our assignments. So I wanted to talk about it. So the next quiz will be multiple constructors and then maybe some more methods with like the for each loop, some other coding, and that'll be on I think it's Monday. I'll put an announcement up tomorrow. And your quiz is ready for tonight, and yeah, I better check this out. I think there's a quiz on Monday. I'm pretty sure it's Monday. Anyway, I just checked my work class since I forgot already. I'll let you know when the next quiz is, and it's going to be on multiple constructors and also just some other method writing. Your quiz is up. It's due Friday night. It's only 5 problems, so I give you 90 minutes. And again, it's best 12 out of 15 instead of best 12 out of 14. But are there any questions right now? Is it?
Yes. Quick question about the try and catch. I was
Yeah,
wondering
go
if
ahead.
you could purposely make it so there's an error and then in the catch portion you put code in that fixes it.
I think you can put anything in the catch block you want. So yeah, you could actually do that because the catch block you might want to say enter like a valid, enter a valid entry. Let's say the user is supposed to be entering data, enter a valid entry, and then if they enter more bad data again, you just rethrow the exception. But yeah, absolutely. My catch blocks are pretty simple. So, but absolutely, you can basically do anything you want in the catch block.
Okay, thank you.
And then the few examples we'll see in this class, we won't be doing. We'll keep it really pretty simple. Anybody else? And if you have a question about your code, just send it to me via email. I'll look at my email right now. But does anyone have Jose or Santos or Jair? Do you have any questions?
Oh, I'm good. Thanks.
I'm going to stop sharing.
Yeah, no questions for now.
I'll stop sharing. So what I'll do now is I'm just going to go, unless there's questions right now, after everyone leaves the room, I'm going to check my email to see if there are any, late night questions about the assignment. Oh yeah, so long. I'm going to stop.
All right.